Alcohols can be used to prepare organic compounds with different functional groups. Part A. HOCH24OH can be oxidized to form HOOCCH22COOH. Part 1. State the reagents and conditions and write an equation for this oxidation. In the equation, use O for the oxidizing agent. So if we start with the reagents and conditions, the first thing we need is an oxidizing agent. So if you look on your reaction map for this syllabus, and you look at the reaction going from an alcohol to a carboxylic acid, you'll see an example of an oxidizing agent, which is potassium dichromate, so K2Cr2O7. But you also need it acidified, so you can write this as H+, or acid, and we need reflux. So this is so that it forms a carboxylic acid and not an aldehyde. If you wanted to form an aldehyde, you could distill with an oxidizing agent in acidic conditions. Now we need to look at the equation. So if we start with our reagents, we have HOCH24OH plus some oxidizing agent, and it's going to produce HOOCCH2 brackets 2 COOH. So going from an alcohol to a carboxylic acid, this is a condensation reaction. So we form water. Now we need to look at what's changed in the two reaction and products. So if we look at the carbons, it might seem like we've got different numbers of carbons because we've got 4 here, but we've got 2 here. But this 2 is not including this carbon and this carbon. So we still have 4 carbons. But our number of hydrogens has changed. And so to balance it with this H2O, we actually need 2 waters to make sure this is a balanced reaction. And looking at the differences in the oxygens, well, we have an additional 2 oxygens here, but we also have 2 from the water. So to balance, we need 4 oxidizing agents. So in this question, you get your 3 marks, your first mark coming from your reagents and conditions, your second mark coming from writing the oxidizing agent as brackets O, and writing water, so that gets you your second mark. And then your third mark comes from correctly balancing the equation. Part 2. HOOCCH22COOH is soluble in water. Explain using a labelled diagram why HOOCCH22COOH is soluble in water. So to answer this question, let's start by drawing out our carboxylic acid or our dicarboxylic acid. So drawing this out, we have our double bond oxygen, our OH group, then we have our CH2 brackets 2, and then our carbon double bond oxygen and our OH. So if something is soluble in water, this means that it's going to react with water and it can bond with water. The most common bonds with water are going to be hydrogen bonds. So a hydrogen bond, if we had with water, we can have the lone pair on the oxygen of the H2O, our 2 hydrogens, a negative dipole on the oxygen, and a positive dipole on the hydrogen. You also need to label that this is a hydrogen bond. Alternatively, you could have had your hydrogen bond from the lone pair on the OH of your dicarboxylic acid, and it would bond to the hydrogen of H2O. And you could draw it like this, but you need to make sure that you're labelling this as a hydrogen bond. So to get the 2 marks for this question, you get a mark for the correct dipoles. So on this alternative one, the dipoles, you'd have a negative dipole here and a positive dipole here on the hydrogen. So you get a mark for your dipoles, and then you get your second mark from making sure that it's going from the lone pair on oxygen to a hydrogen and that you've labelled it as a hydrogen bond. that gets you your second mark. Part B. HOOC-CH2-2-COOH and HOCH2-4OH react together to form polymer E. Part 1. Draw one repeat unit of polymer E. The functional groups should be clearly displayed. So, to start this, we need to draw out our dicarboxylic acid and our diol, and look at what groups are going to be lost and what bonds are going to be formed. So, drawing out our dicarboxylic acid, we have our OH group, and then this is connected to a carbon, double bond oxygen. We have our CH2 group that's times by 2, and then we have our C double bond O, and then another OH. So then we're reacting with this diol, so we have our OH, and then we've got CH2 brackets 4 and our OH again. So what's actually formed is we have a carboxylic acid and an alcohol, and this forms an ester. So we get rid of this hydrogen, and this OH group at the end. So we have this ester bond in the middle, and it's all connected, and we've got a repeating chain, which is shown by these dotted lines. So we're only asked to show one repeat unit, and our repeat unit is going to have this ester bond in. If we were asked to draw 2, it would have 2 ester bonds in. And we've clearly shown our functional groups. So this is polymer E. It's an ester polymer, and it's a condensation polymerization, which means you would form water, but we're not asked to write an equation, so we don't need to worry about water at the moment. To get the 2 marks for this question, you get a mark for the ester link, and then you get a mark for the rest of the structure being correct. Part 2. Governments are encouraging the development of biodegradable polymers to reduce dependency on persistent plastic waste derived from fossil fuels. Polymer E is a biodegradable polymer. Suggest why polymer E is able to biodegrade. So, as we already discovered in part 1, polymer E has an ester group, and this ester group can be broken down, which is why it's able to biodegrade, because it can be broken down via hydrolysis. To get the mark for this question, you need to write this statement. Ester group can be broken down via hydrolysis. Part 3. A large yield of polymer E can be obtained by reacting a diacyl dichloride with HOCH2-4OH. The diacyl dichloride is prepared from HOOC-CH2-2-COOH. Complete the equation for the formation of a diacyl dichloride from HOOC-CH2-2-COOH. So this question is relying on your knowledge of your chemistry reaction map. So if you found this question hard, I'd recommend going back, revisiting and trying to learn it. So the reagent that you need from going from a carboxylic acid to an acyl chloride is SOCl2. And because we're making a diacyl dichloride, that means we need 2 of these. So an acyl chloride has a double bond carbon and then a Cl. So what happens when you go from a carboxylic acid to an acyl chloride is the OH is replaced with a Cl or a chlorine. But the rest of the structure stays the same. So you have your CH2, and then again your second bit to make it the diacyl dichloride, you need to replace your other OH with a chlorine. And then balancing the equation, you get sulfur dioxide and you get 2, and you also get hydrogen chloride, and you get 2 of these because you've lost your 2 H's in your OH, and you've got your excess chlorines from when you doubled your SOCl2. So to get the 3 marks for this question, you get a mark for writing SOCl2 as your reagent. You get a mark for the correct structure of your diacyl dichloride, and then you get your 3rd and final mark for correctly balancing the rest of the equation.